Stoichiometry in solutions deals with these three rules right here. But before we begin this, we have to figure out what a solution actually means. So a solution is a homogeneous mixture. A homogeneous mixture is any mixture where you can't differentiate between the different elements that are in the mixture. For example, if potassium and iodine were mixed together in a solution, you would not be able to just go in there with a spoon, for example, and just take out the mixture. A salad, for example, is not a homogeneous mixture. It's a mixture where you can see with your naked eye the different components of the salad, for example, the tomatoes, the lettuce. But with a homogeneous mixture, you won't be able to see those parts. It'll be so well dissolved. Okay? So, in stoichiometry with solutions, we have to look at a new equation, which is C. C equals N over V, where C is concentration, V is volume, and N is mole. Okay? So, volume must be in liters, and concentration equals moles per liter. These are the rules that we have to follow. Okay? So, I'm just going to erase this really quickly so we have more space to work. But the reason that we call it stoichiometry is because we have to use a lot of the equations that we used in stoichiometry in the previous unit. So, for example, N equals N, like capital N over Na, which is the particles to mole, or moles to particles, or N equals lowercase m over capital M, or moles equals mass over molar mass, right? So for this example, we have to use equation. So if you recall, it's this. Okay? So N equals 18 grams over 30. Let me just make sure really quickly. Yes, 39. Okay? So 39. Okay? This is grams per mole. And when you're dividing, you can take these out. Okay? So let's just divide that. So you'll get N equals 0.46 mole. Okay? So today, just for the lack of space, let's write that over here. Okay? And let's go ahead and erase this. Normally on a sheet of paper you would not have to do this, but today, since we're working with the lack of space, it's easier if we do. So it's right over there for future reference. Now we can just go ahead and divide, right? No, you can't do that because, as you can see here, you have 400 milliliters, okay? And volume must be in liters. So what do? We know that 1 liter equals 1,000 milliliters, right? So which means that to go from milliliters to liters, we have to divide by 1,000, right? So that's what we do. We take 400 divided by 1,000. And if I'm not mistaken, we should get 0.4, but let's just make sure. Yes, 0.4. Okay? Again, for lack of space, we'll just write that over there. 0.4 liters, okay? From here on, pretty straightforward. If you recall, the equation was C equals N over V. So, again, C, okay, equals N don't forget to include your units, over V. Oh, sorry, that is a 4. Okay? divide that and you should get moles per liter. So let's do that really quick. There you go, 1.15 moles per liter. That is the concentration, right there. Okay? So let's write in our liquid chalk just to make it 100% accurate and professional. Therefore, the concentration of the potassium iodine mixture is 1.15 moles per liter. Okay? So, after all of this, you might be wondering, well, I know what moles are and I know what volume is, but what is concentration? So, I've already told you that it's moles per liter, but that doesn't really help, does it? A concentration is basically just how saturated the solution is. When I say saturated, I mean how much solute is there per solvent, right? A solute is basically the substance that gets dissolved, and a solvent is the substance that dissolves. So for example, let's say you're trying to dissolve salt in water. Salt would be the solute and water would be the solvent. A really simple way to remember this is the substance that's in the larger quantity would be the solvent, and the substance that's in the lower quantity would be the solute. That's how I remember it, okay? Because of course, if the solute is larger in quantity, you won't be able to dissolve it. Just for example, if you wanted to try to dissolve a bucket of salt with a cup of water, that wouldn't really work. All that would happen is that the salt would get moist. So in the same way, you can't really have that. That example that I just gave you, the bucket of salt, would be a supersaturated mixture, right? So let's just erase this and I can give you the definitions right now. Okay? Okay. So unfortunately, the liquid chalk does not erase as easily, but let's just make a box right here. Shall we? So a saturated solution is one where there is enough solute and solvent for the mixture, the solution to dissolve completely. So no more solute can be dissolved. Okay? Unsaturation or unsaturated so unsaturated solutions are solutions where it's not completely dissolved yet. You can still add more solute to the solvent and it'll still be able to dissolve. So more solute can be added. And the last one, supersaturation. This would be a solution where there is more solute than can be dissolved. So that bucket of salt, for example, there's so much solute that even with the liquid solvent, so the water, it won't be able to dissolve. It'll just be moist. So more solute okay, so that is saturation. But what does it really have to do with concentration? Well, when you're calculating the concentration, you're basically looking at which one of these does the solution fall into. Is it saturated? Can there be more dissolved? Is it unsaturated? Is it saturated? No more can be dissolved? Is it unsaturated? Can more be dissolved? Or is it supersaturated? There's so much that it can't possibly dissolve everything. If you want to look at a more real life scenario for supersaturated, let's say you took a cup of water and you put in 4 tablespoons of salt. It won't be able to dissolve all of it, so some of the salt will sit at the bottom of the cup. So you're basically calculating that, right? Which one of these categories does this solution fall into? Well, you can figure out how much solute you would have to make it saturated through the internet or through your own experiments. And once you figure out the concentration level, you can determine which one of these categories would it fall into. Okay, so thanks for watching. Hope you've had a wonderful time, and hope to see you next time.